Okay, we solve quadratics 3 different ways. One way is we solve like regular, and by regular I mean there's just one x. We subtract the 12 from both sides, square root, we get x equals plus or minus root 3. The next way was by graphing. Graphing is great if you have a graphing calculator or Desmos or some sort of app like that, but not as useful if you're doing it by hand. Solving by factoring is magical, especially if it works. You should always try and factor first. However, not everything can be factored. In fact, a lot of things can't be factored. So we need another tool. Today we'll talk about that tool. It's called completing the square, or CTS. The point of completing the square is to take a quadratic that originally couldn't be factored and write it in such a way that it can be factored. We turn it into something of the form, well, x plus something squared, where this is some number, x plus something squared. The steps I'm going to follow are written out over here. This, again, should be review for you in this class, if you're knowledge 2 trig or something of the sort. But I'll go through it slowly, because I think it needs to be taught like it's brand new for most of us. The first thing I do is I subtract c from both sides. Well, right now my a term is 1, my b term is 8, my c term is 12, so I subtract 12 from both sides. That gets me x squared plus 8x equals negative 12. I will leave this gap here every single time. I always leave that space when I complete the square, and you'll see why in a second. Next, you divide everything by a. We just did step 1. Step 2, divide everything by a, but a is 1, so let's not bother with that. Third, calculate b over 2 squared. In another color, I'm going to find that b is 8. So b over 2 is 4, making b over 2 squared 16. Now this b over 2 squared equals 16. This 16 is a really special, useful, helpful number in this case. I'm going to add 16 to both sides of the equation. If I add it to both sides, the equation's still true. The left side still equals the right side. Only now the left side has been changed or manipulated in such a way that it's factorable. That's what's so great about that b over 2 squared number. This can now factor. It factors into x plus 4 times x plus 4, which is really x plus 4 squared. My 4s are getting worse as I go. X plus 4 squared. X plus 4 squared gives us x squared plus 8x plus 16, but now I've taken an equation that had 2 variables and written it with just 1. At this point, I've completed the square. The square is now complete because, look, there's my square. I want to keep going and solve, so I'm going to square root both sides and get x plus 4 equals plus or minus 2, because the square root of 4 is 2. Subtract a 4 from both sides. X equals negative 4 plus or minus 2. Negative 4 plus 2 is negative 2. Negative 4 minus 2 is negative 6. Negative 2 and negative 6 are my solutions. We just solved by completing the square. Now please note, if these numbers are very, very clean, meaning they're whole numbers, they're integers, or they're pretty fractions, there's no radical in it anywhere, that means that this could have factored. This is x plus 6 times x plus 2. If you ever get whole numbers for solutions, you have a very factorable problem to begin with, because the whole numbers you get are actually the roots. They're the factors. But we'll worry about that later. There was a simple problem that could be factored. This one over here can't be factored. I'm going to solve it following the same steps. I'll change my color so we don't get too confused here. Add 12 to both sides. It says subtract c. If c is negative 12, then subtracting negative c becomes adding c, which is adding 12. So now we have x squared minus 10x equals 12. Next, I calculate b over 2 squared, because remember, there's no a term to divide by. b over 2 is negative 5, so b over 2 squared is 25. So I'm going to add a 25 here and add a 25 here. The left side can now factor, even though I wrote that 10 like I'm just learning how to write in kindergarten. No, my kindergartner can write better than that. You try using these pens someday, you know? They're not as easy as you think they are. That square is pretty bad too. You want me to move on, so I'm going to move on. The left side can now factor. It'll always factor in this really handy way. Whatever b over 2 was, that number always goes there. So this is going to be x minus 5 squared equals 37. So that b over 2 number is worth hanging on to because the left side factors into x plus b over 2 squared. In this case, b over 2 is a negative number, so it's x minus 5 squared. We can square root both sides, and we get x minus 5 equals plus or minus the square root of 37. So add 5 to both sides. X equals, I have to slow down for my pen's sake, 5 plus or minus the square root of 37. If you wanted to find the decimal, which is going to be a little bit over 6, you could get answers of like 11.1 and negative 0.1 or something, 1.1. And if 37 could break down, if this is a radical I could simplify, I would simplify it, as will you. But it can't, so I don't. There's my solution. Just writing this for a solution is beautiful. And if we wanted to check that, we could plug in 5 plus root 37 for x here and here. We would get out exactly 0. Okay, what if the b value is odd? The first two I did had even b values. Well, we still follow the same process. I'm going to add 7. So x squared plus 5x equals 7. Then I'll calculate b over 2 squared. Well, b over 2 is, I'm just going to leave this 5 over 2, leave it a fraction. And you will find it actually goes very cleanly and nicely if you do it this way. Some of you are just going to be insistent on doing decimals. And that's fine. I mean, 5 over 2 is 2.5. It doesn't feel too bad, although they can get messier. But trust me, the fractions are really nice. There's b over 2. So b over 2 squared is 5 over 2 squared, which is 25 over 4. So I'm going to add a 25 over 4 here and a 25 over 4 here. Now, this is where students start to really get nervous because you've not been forced to fight with fractions enough in your life. And that's just a fact. They are everywhere. They are unavoidable. You need to be able to deal with fractions. The left side factors. But the good news is it factors into x plus b over 2, that quantity squared, b over 2 in parentheses then squared, and we know what b over 2 is. So this will factor into x plus 5 over 2 squared. That's how the left side factors. The right side needs a common denominator. 7 over 1 becomes 28 over 4. So we get x plus 5 over 2 squared equals 53 over 4. And now I solve this. I get the x by itself. Here's the beauty of this method. This denominator will always be a perfect square. Unless something really crazy is happening or you've done something wrong. So we get x plus 5 over 2 equals plus or minus. Remember, we square both sides with plus or minus. Now the top can't square root. We'll just leave that root 53. The bottom can. The square root of 4 is 2. And these will always match. So now I'm going to subtract 5 over 2 from both sides. And I can write this as one fraction because of the common denominator. So we get x equals negative 5 plus or minus the square root of 53 over 2. That has two solutions. Negative 5 plus root 53 over 2 and negative 5 minus root 53 over 2. Two different pieces. If you wanted to actually calculate that, you can. This will be the one time I show how to do it on the calculator. Go away, all of you. So in parentheses, if you had to do in parentheses, negative 5 plus the square root of 53, double close parentheses because there was an open one with the square root. So I have to have two closed parentheses. And divide that by 2. There's one solution. Press second enter. Go back and change this plus to a minus. There's the other solution. And I can check both of these if I wanted to. I might as well, because what I can do now is I can do, what was the original equation? I can do my previous answer. Second negative is previous answer, so negative 6.14, previous answer squared, plus 5 times the previous answer, minus 7. This has to be exactly 0. If this isn't exactly 0, we've done something wrong. Oh, that's 0. Okay, that's the calculator calculating 0. It's 0.00000. It's 11 zeros after a decimal and then a 1. So, good enough. Completing the square. Okay, what if the b value is already a fraction? So in the last time we had an odd b value, now the b value is already a fraction. Nothing is going to change, same process. I'm going to start by adding the 2 to both sides, getting me x squared plus 3/4 x equals negative 3. Now calculating b over 2 squared here seems tricky. It's actually not so bad. Sorry for all this pen color changing. The b value is 3/4. b over 2 is actually not hard to find. You just double the denominator. It's 3/8. And if that fraction could reduce, I would definitely reduce it. But it can't, so I don't. So b over 2 squared is 9/64. So I'm going to add 9/64 here, and add 9/64 here. And again, you might see this and think, no, these numbers, no, why are you doing this to me, to Mr. Stoke? Why? It's not bad because we know how the left side factors. We know what b over 2 is. This is going to be x plus 3/8 squared. And then here I need a common denominator. Well, okay, that's a bit of doing. I do 64 times 3. Negative 3 times 64 is negative 192. So I get x plus 3/8 squared equals negative 183/64. Now we square root both sides, and we get x plus 3/8 equals plus or minus the square root of negative 183/64, and over 8. The square root of 64 is 8. And hello, we have a square root of a negative. We can't have a square root of a negative, so this has no real solution. And now you might be frustrated for other reasons, like why did we do all that work for something that can't be solved? Well, I'll eventually show you a way where you can always tell if something can't be solved. But it's also worth knowing how to do it. You know, it's just the example up to this point was worthwhile. And also, we'll talk about a way to actually solve this in our next video. So hang on tight for that. But the point here is if the b value is a fraction, you just keep going. The next level is, well, okay, if b is a decimal, just start doing this, okay? Like, stop saying, what happens if these things are annoying? I'm getting tired of making that annoying voice. I'm going to stop. You just do it. So right now, b is 3.7. So b over 2 is 1.85, because that's half of 3.7. So b over 2 squared is whatever that number is squared. I don't really care what that is. You just put that number there, and you put that number there. And then the left side factors, 1.85 squared equals whatever that number is. I don't really care. You square root that stuff, and you just keep going. You just keep doing it, okay? Nothing changes. You just keep doing it. I should probably actually do it. No, you can do this. Come on, people. Okay, what if a isn't 1? This is something new now. Nothing actually changes. It's just it's going to look a little bit different. So this one I will go through completely, and I'll go through it slowly. Subtract the 10 first, giving us 3x squared minus 5x equals negative 10. Divide everything by 3. X squared minus 5/3 x equals negative 10/3. Again, I don't do decimals. You might want to, but I don't. Completing the square only works if the a value is 1. Now that doesn't mean if you have a problem where the a value isn't 1, you can't do it. That just means take your a value and make it 1. You have that kind of power. Divide everything by the a value. Now the a value is 1. I'm going to leave these as fractions, not as decimals. You can do as you choose, but I think you'll see in the long run the fractions are actually better, cleaner, easier. My b value is negative 5/3. So b over 2 is negative 5/6. So b over 2 squared is 25/36. Left side factors. Pause the video. Think about it. How does this factor? What am I going to write there? For the record, I just got a common denominator, did this times 12 on top and bottom. Times 12 times 12. This is going to be whatever b over 2 was. So x minus 5/6 squared. This one also ends up having no solutions. I can live with that, you know. It's all right. I'm going to square root this, square root this. We get x minus 5 over 6 equals plus or minus the square root of, well, negative 120 plus 25 is negative 95 over 6. I could add 5/6 to both sides, so x equals 5 plus or minus the square root of negative 95 over 6. And this actually has no real solution. But we'll come back to it next video and show how it does have a solution. Finally, I'm going to show another way to do this. Okay, this way is kind of more cumbersome for a lot of people and tougher to understand, but quite frankly, it's more valuable in the long run. In a much, much later chapter called conic sections, we're going to have to complete the square using this method. So I want to show it to you now. Quite frankly, if you don't do it now and don't use it now, you'll survive. But I want you to see it, so when we have to do it later, you're not seeing it for the first time. Because that, ladies and gentlemen, is good teaching. First step was subtract c from both sides. This step is now different. For the record, this means a does not equal 1. I'm writing this. A does not equal 1. If the a value is not 1, don't divide both sides by a in this version. In this version, factor out the a. So we get x squared plus 4x equals negative 3. And now I do something incredibly sneaky. Something that we talk about that you can do, but we do it very rarely. I'm going to add 0, because adding 0 doesn't change anything. So right now, the b value is 4. So b over 2 is 2, and b over 2 squared is 4 again. That's kind of weird. We're back to 4. Well, I'm not going to add 4 to both sides. I'm going to add 4 here and subtract 4 here. Because what I really just did was I added 0. I added and subtracted b over 2 squared to both sides inside the parentheses because that's adding 0. And adding 0 doesn't change anything. So this equation here is the same as this equation here. Nothing changed. Now, this part and just that part can factor. Those 3 terms on the left can factor. I'll go back to yellow. So this is going to give me 2, and then in this part here is x plus 2 squared minus 4 equals negative 3. Distribute this 2, so it's 2x plus 2 squared minus 8 equals negative 3. Then add the 8 to both sides. I can't say equals anymore because I'm changing this a little bit. X plus 2 squared equals 5. From here, I could divide by 2, square root, and solve. Yeah, let's do it. I'll come over here. So x plus 2 squared equals 5 over 2. Square root both sides. X plus 2 equals plus or minus the square root of 5 over 2. And so x will equal negative 2 plus or minus the square root of 5 over 2. Calculate that decimal if you'd like, but there we have it. That's the other method of completing the square. It is going to be necessary eventually, but not necessary now. So depending on what type of student you want to be, you can learn it now or you can learn it later. Thanks for bearing with me. Next video, we'll see something totally different and really incredible.
Hey, you did it. You watched a whole math video, or you at least skipped to the end here. Either way, thanks for watching. I hope it was helpful. If it was helpful, maybe share it with a friend in your class who could also use it. You can subscribe to follow more videos. You'll see links popping up on the corners to watch previous and past and good videos. You can always leave a question down below or just add a comment. And I hope you have a wonderful day. Thanks for watching.